Look, if you are sitting there staring at a Cambridge mathematics past paper and your mind is just completely blanking on those high mark vector questions, you are in exactly the right place. Welcome to this explainer on Cambridge Mathematics Topic 3.7, Vectors. Whether you're navigating the core syllabuses like 0580, 0606, 4024, 4037, or 4040, or you are pushing for the absolute top grades in the advanced 9709 framework, mastering magnitude, unit vectors, displacement, and position vectors is absolutely essential. Why? Because this topic appears in every single examination series. It is unavoidable. But today, we are not just looking at math in the traditional, boring way. No, we are treating this exact paper like a high-stakes 90-minute football match. We are going to use a football playbook strategy to completely outplay the defense. And in this scenario, the defense represents those tricky, invisible question barriers the examiners set up to test you. We are going to break down formation, tactics, and execution so you can confidently tackle the absolute toughest exam questions they can throw at you. Our strategic playbook today is broken down into 5 distinct modules. Module 1 is the challenge. Module 2 is the vector framework. Module 3 covers technical methodology. Module 4 reveals the examiner traps. And finally, Module 5 dives into evaluative thinking. All right, before we even step onto the pitch and hear the starting whistle, we absolutely must address the ultimate red card. This is highlighted year after year by senior examiners across all Cambridge math papers. The classic mistake is not a calculation error. Let me repeat that. It is not a calculation error. The biggest mistake is providing generic answers that completely ignore the specific scenario of the question. You can have all the theoretical skill in the world, you can memorize the entire textbook, but if you do not play the actual conditions of the pitch in front of you, you lose the points. Period. If a question gives you a specific real-world vector application, like the velocity of a ship or the force on an object, you cannot just regurgitate a standard definition. You have to link every single mathematical point directly to that given context. Otherwise, the examiner is just going to give you 0 marks and move on. Let's look at 2 classic student missteps to really understand this. Imagine our 2 players who are currently struggling in the midfield, Alex and Sam. On the left side of your screen, we have Alex. Alex treats the math exam like it's a pure memory test. Alex overloads the paper with raw mathematical facts, writing down every single vector formula they can remember, but offering absolutely 0 analysis of the actual problem. It's like a player who knows all the fancy footwork but refuses to actually pass the ball to a teammate. On the right side, we have Sam. Now, Sam is a different story. Sam rushes the play. The clock starts ticking, panic sets in, and Sam completely misses the tactical command words in the prompt. Sam calculates a position vector when the question explicitly asks to evaluate or show that. It is basically shooting wildly off target. Look at those red pen marks all over their answers. They both drop massive marks. But don't worry, because we are going to fix their formations and yours today. Section 1, the vector framework. Let's look at our core principles. To win this match, you must deeply understand the exact definitions and causal relationships of your players on the field. Topic 3.7 is all about precise theoretical architecture. Think of a position vector as a player's exact coordinate on the pitch relative to the center circle, which is our origin. That tells you where they are standing. Now, displacement? That is the pass itself. It is the movement from one specific player to another. The magnitude is the pure power or the total distance of that pass. How hard did they kick it? And finally, the unit vector. This is a brilliant concept. The unit vector is the pure tactical direction of the play, stripped of its power. It has a magnitude of exactly 1. It just tells you the direction the ball is traveling. You need this precise architectural framework locked into your mind, because you cannot build a winning strategy if you don't know what position your players are actually playing. So the crucial point here is how you actually use these definitions in the exam. The principal examiner reports explicitly state that candidates who demonstrate analytical depth and reference cross-topic connections achieve significantly higher marks. What does that mean for you? It means academic benchmarks for vectors require logical, structured reasoning. The assessment framework completely prioritizes analytical depth over superficial breadth. You can't just know the definitions on a surface level. You have to integrate them with systematic analysis and evidence-based reasoning. Can you connect your vector knowledge to trigonometry? Can you use it alongside calculus or coordinate geometry? Because the top-tier candidates absolutely do. They see the whole field, not just one small patch of grass. Section 2, Technical Methodology. Let's get into the procedural framework. In Cambridge math exams, writing down your final answer is just the ball crossing the goal line. Sure, it looks great, but the method marks are the spectacular, strategic build-up play that actually gets you there. Marks in this specific section are highly dependent on your procedural framework. Look at these 3 steps. Step 1, you must carefully extract data from the text and tables provided. Pull the exact numbers out of the scenario. Step 2, meticulously interpret the vector relationships. Ask yourself, are these vectors parallel? Are they perpendicular? Does their dot product equal 0? Step 3, draw strict, evidence-based conclusions based solely on the data you have analyzed. You cannot guess. Every single line of working out must naturally follow from the line above it. That is how you secure the method marks, even if you make a tiny arithmetic error right at the very end. We are about to decode the exact presentation conventions examiners look for. But before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, to secure those precious game-winning method marks, your information presentation must follow strict conventions without a single deviation. You need proper headings to organize your thoughts. You absolutely must use the correct mathematical terminology. You need appropriate formats for your vectors. If the question uses column vectors, you use column vectors. If it uses IJK notation, you reply in IJK notation. And you need clear annotation throughout your working. Do not skip steps because you think it's obvious. You have to explicitly show the examiner exactly how your midfield connects to your strikers. If you just write down an answer with no working, the examiner assumes you are guessing and you get nothing.
Section 3. Avoiding examiner traps. The most common mistakes students make. Stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back to the match. This is exactly where the defense usually falls apart under pressure. Let's look at exactly why thousands of Russian candidates lose marks right here and how you can break through their lines. Principal examiner reports highlight these top 3 mistakes year after single year. Number 1, students confuse cause and effect in vector relationships. They mix up which vector is defining the movement and which is defining the position. Number 2, they forget format and presentation. A classic error is writing standard coordinates when a vector format is explicitly asked for. Number 3, as we discussed earlier, failing to specify answers to the context of the problem. I highly recommend creating a quick memory hack using the first letters of key vector terms to anchor your focus during the exam. When the pressure is on, let these 3 warnings be your absolute mental defensive line.
This slide brilliantly illustrates the transformation we're talking about. Look at the split screen here. On the left, we have Alex's original, flawed, generic answer. It's just a wall of textbook facts. This gets 0 method marks. It is covered in red pen. But on the right side, we see the transformation. This is a context-specific, justified application. And the secret weapon here is the Peel framework. Point, evidence, explanation, link. First, you make your mathematical point. Then you show the numeric evidence from your calculations. Next, you provide the explanation of what that calculation actually means mathematically. And finally, the link. You link that mathematical reality back to the real-world context of the question. By linking every single point directly to the given scenario and explaining the evidence clearly, this answer guarantees maximum method marks. Watch as those red marks turn into beautiful green check marks.
Section 4, Interactive Workshop. It is time for a live practice session.
All right, let's put you under a bit of exam pressure. Take a quick look at this complex data table. You have 60 seconds on the clock and a real exam. I want you to challenge yourself right now to extract the core displacement and position vector trends. Scenario A shows a particle's position vector, defined by a specific set of coordinates. Scenario B introduces a completely different velocity vector shifting over time. Can you instantly see the trend analysis? Do you notice how Scenario A is static while Scenario B is dynamic? Can you extract the data and find the displacement between the 2 particles at time equals 3? The clock is ticking. Your ability to quickly scan this table, ignore the useless noise, and interpret these vector relationships under intense time pressure is exactly what separates the top-tier candidates from everyone else. This is where you prove you have analytical depth.
Now, if you struggled to find the trend in that data table, or if you felt the pressure of the clock, I want you to remember this incredibly powerful quote straight from the principal examiner. Listen closely. Top-scoring candidates demonstrate evaluative thinking by questioning assumptions, considering different perspectives, and justifying decisions with evidence. Finding a flaw in your own practice answers is not a failure. It is a massive victory. It means you are thinking critically. Top-tier execution comes from actively questioning your own mathematical assumptions. You shouldn't just write down a vector calculation and assume it's right. You need to justify every single move, every single pass on the pitch with hard, calculated evidence. Section 5, Evaluative Thinking and the Final System. Let's bring it all together. When Cambridge questions ask you to evaluate or compare, for example, comparing two different vector paths or two distinct mathematical models, true comparative analysis means you aren't just finding the easy similarities. You must explicitly detail the differences, and you do this using comparative connectives. Words like whereas, conversely, or in contrast show the examiner you are thinking at a high level. But you can't just state the differences. You must support each comparison with actual numerical vector evidence from your calculations. And finally, to get the absolute top marks, you must draw conclusions on the relative importance of those differences. Which model is actually better for the given scenario? That right there is what analytical depth looks like in action. So here is your ultimate cheat sheet, the final system. These are the 3 rules that guarantee top marks when you walk into that exam hall. Rule number 1, command word decoding. You have to read the prompt carefully. Are they asking you to calculate, to show that, or to evaluate? Play the specific ball they serve you. Do not give an evaluation if they just want a calculation. Rule number 2, peel framework application. Make your point, show the mathematical evidence, explain the technical step, and link it firmly back to the question context. Rule number 3, the time management matrix. This is huge. Do not spend 10 minutes on a simple 2-mark displacement calculation, leaving you 0 time for the 8-mark evaluation at the end of the paper. Implementing these 3 playbook rules ensures you are constantly evaluating the quality of your evidence and managing the clock like a professional. As you head into your next past paper practice session, you need to start scrutinizing your own work exactly like a Cambridge examiner would. Questioning your own models is the ultimate defense against losing silly marks. Look at the question on the screen. What underlying assumptions are limiting your vector conclusions, and how will alternative interpretations alter your final evaluation? Ask yourself this every single time you finish a complex problem. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.